Controlling fire was a turning point in the human evolution. Throughout our history, we use fire for warfare, to build machines or provide energy. But fire is still a natural element that, with becoming wild, can destroy not only our landscapes, but also invaluable remains of our history.
La Grèce dévorée par les flammes.
Fires engulfing villages and threatening the ancient city of Olympia.
Da Olimpia la montagna è completamente divorata.
Και να κατευθύνεται προς τον αρχαιολογικό χώρο και το αρχαιολογικό μουσείο.
The problem of wildfire is a huge problem, especially for Italy, because of course we have many wildfires that could be very dangerous and treat population directly.
1 million inhabitants on a total population of 10 million. It means 10% of the total population are living in the forest. So the early warning system is quite useful for the Forest Service in order to make the intervention in the beginning. So it's much easier to suppress the fire while it starts.
FireSense is an EU project addressing the important problem of protecting cultural heritage and archaeological sites from the risks of fire and extreme weather conditions. This is an important problem because most of archaeological and cultural heritage areas are located in areas surrounded by dense vegetation, like in the Mediterranean region, so the risk of fire is very important.
This is a system to help the wardens or security guards monitoring the site, because there is usually just a single person, and the archaeological site is 1 kilometer by 1 kilometer area, so you cannot stand in a certain location all day long.
In the fire system, we are trying to use different technologies and to see different modalities, sensor modalities, and to see how they can be combined to improve the results. So, for instance, in order to detect flames, say, you can use visual cameras, which are using visual characteristics such as flickering and color, etc. On the other hand, you can also use infrared cameras, and normally speaking, infrared cameras will be more accurate in detecting the flames, because this is basically a heat signature. But in some cases, these cameras are not well calibrated, or they need to be well calibrated to detect that. So in those cases, the information that we get from the visual cameras can be complementary and improve the results.
Recognizing fire seems obvious for the human eye, but automatic detection systems need to be trained. The FireSense project developed algorithms based on computer vision and pattern recognition, capable of extracting automatically the different characteristics of fire. The system provides in real time alarms for the detection of flame and of smoke from video and infrared cameras.
This is one of the infrared cameras operating in the SWIR band. This is another camera operating in the LWIR band. They get different views, different frequency band views of the same area, and they are these squares mark the location of the hot spot.
The flame can be detected by the heat, or by the heat and the movement and the disorder analysis of the flame. The flame is detected, and you see in time that the temperature is increasing, and the high temperature will go above a threshold that is displayed here, and we have an alarm here that is triggered.
The FireSense system can also protect cultural heritage located inside buildings. A passive infrared sensor was developed for a cost-effective deployment in interior spaces.
This is a typical motion sensor, so it's a very low-cost device. We extract the signal coming from the device. As you can see, this is the signal coming from this device. It detects motion. When I wave my hand, the you will see some activity in the screen. And I'll simulate an uncontrolled fire now using this lighter. And as you can see, the fire is detected now. We have this sound alarm. This is how this system works. It detects the flame flicker, and using the flame flicker, it detects wildfires or uncontrolled fires inside the buildings.
We are also deploying wireless sensor networks which are measuring temperature and humidity. So it could be that if one of these sensors actually reports a higher than usual value for the temperature, the cameras could turn automatically to see whether there is some indication of fire or smoke in that case.
These are, relatively speaking, smaller battery-operated nodes, and their capabilities are limited. But by collaboratively sensing the environment and by relaying in a multi-hop manner the information measured from a distance, they can also bring out the necessary information from the actual field.
These sensors, placed to form of appropriate grid of information, are transmitting temperature readings and humidity measurements through the wireless sensor network. This information is sent to a data collection center where they are processed, analyzed and stored. In the case of a fire approaching the site, the data transmitted can not only trigger an alarm, but also indicate the direction and speed it propagates. In addition, local weather stations installed on site provide valuable data of temperature, humidity and wind speed. All this information coming from the sensors needs to be treated simultaneously. A novel and innovative data fusion mechanism has been developed to analyze and merge this heterogeneous data. The system can then issue an alarm level corresponding to the threat.
Another aspect of FireSense is dealing with fire management, and specifically with modeling the fire propagation after a fire is started. Fire propagation estimation depends on many factors such as topology, vegetation of the area and weather conditions.
The software gets as input the 3D topology of the area, the current weather condition through the local meteorological stations that we have installed in the area, but we can also use forecast information. And another significant factor for the estimation of the fire propagation are the fuel models of the area. For the vegetation classification, we have used coordinate cover maps for the areas which are far away from the archaeological site, and from the areas which are near to the archaeological site, we have used high-resolution satellite images, and we apply image processing and pattern recognition techniques in order to classify the vegetation. The software supports simulation with multiple ignition points. We can also have different weather conditions during the simulation, and also it supports 3D visualization and 2D visualization of the fire.
The end result of the FireSense system is materialized in the control center. The user, through the different elements of the software graphical interface, receives the early warning signal and can access and control the different sensors or estimate the fire propagation. The system doesn't require specific hardware and can even be installed on laptops. The FireSense team consists of 10 partners from Europe and the Mediterranean area and combines the expertise of research institutes, enterprises and state authorities. Together, with the support of the European Union's 7th Framework Programme, they worked during 3 years to develop the FireSense system. They met regularly to assess the progress of the project's development and confront their ideas.
The threshold, I guess it's common for all frames, and it's calculated based on the swable energy of the block.
The FireSense project also became a platform for international experts to exchange their experience and their expertise in the fields of fire prevention, fire detection, and firefighting. The system has been installed in 5 partner sites, each presenting specific particularities. The archaeological site of Kabirion in Greece is situated 8 kilometers from the city of Thebes, the largest city in the ancient region of Boeotia, major rival of ancient Athens, and famous for its victory against Sparta. The site, discovered in 1887, was burnt in the summer of 2007 and remains under risk of flooding during winter. Rhodiopolis, located near Antalya in Turkey, received its name from the inhabitants of Rhodes. Most of the visible ruins in this ancient city date from the Roman and Byzantine periods. The ancient city was discovered after a forest fire in 2000, and excavation of the site is still being carried out by the Akdeniz University. Listed as a heritage building by the Turkish Ministry of Culture, Dodge Hall is located on a wooded hill. Situated in the campus of the Boğaziçi University, the building is demonstrative of the most monumentous in Istanbul and has to be protected from both external and internal fires. The Temple of Water is a Roman temple located on a mountain within the Djibel Zagonen National Park. It took its name from the sources that still spring from below the temple and supplied water through a 123-kilometer-long aqueduct to the ancient city of Carthage. The Monteferrato Galcetti Park, situated in Prato, Italy, demonstrate the need for the protection of both cultural and environmental heritage. Situated in a pinewood forest, the 16 hectares environment park is classified as protected area for the richness of its biodiversity.
The FireSense system was installed in a cultural heritage site of community importance of the Natura 2000 network that is called Monteferrato Park. And in this area we installed for camera for detection of fires and the control center for getting the alarm of fires.
We developed systems and algorithms in our labs in the FireSense project, and then we detected 2 actual wildfires this summer, one in Olympos, the other one in very near Rhodiopolis. It was very fulfilling to see that our systems are used, and they protected both nature and archaeological sites from wildfires.
I either wanted to be an archaeologist or wanted to be an electrical engineer. But after, let's say, more than 30 years, this whole setup was very nice to put me again on the work together with archaeological sites and also national heritage sites. So as a result, personally, as an engineer, I try to help the project, but personally, this is like a paradise for me because it has the mountains, it has the archaeological sites, And when we put our sensors on this environment, it's a joy to work in this field.